now. So class is being recorded. I'm taking a screenshot of your guys in my Zoom, so that way I know who is here and who is not. All right, so good morning everyone officially. We are going to start our class of today. So today we are starting the second week of our semester, and we are going to start our lecture number 3. My goal is to finish with Pi's defined function today, and then on Wednesday we can start practicing. When I say practicing, it's not practice number 1. Practice number 1 is an actual assessment of the class. Practicing is just I want to get ready you for quiz number 1. I want to know how you prefer to submit your work. So we are going to talk more about that on Wednesday. Just feel free to bring whatever you feel like, whatever you like. For example, if you are working on an iPad, you are welcome to work on an iPad and then submit your work from the iPad. If you prefer handwriting, I welcome you to print out the document or write down the exercises and make a document with your handwriting, then scan it or taking a picture of it and create a PDF to submit on Blackboard. Okay, so that's the goal for Wednesday. Wednesday I want to go over those technical stuff. Let me close this. Okay. So today I'm going to start with going back to the definition of absolute and local extreme values, because I made a mistake on the definition of local maximum and minimum values. Okay, because I forget one important detail is that for the definition for local maximum is not exclusively just to be greater than, it could be equal. So let me just write that here to simplify the definition, and then we are going to proceed to do this exercise again, and we are going to identify the absolute and the local extreme values. Okay, so when we're talking about let's go here, definitions. Okay, you can read there. How is my video fit? Is this good? Are you seeing this clearly? Let me know if not. Okay, so when we are going to talk about the local maximum, we are going to say if this is a value of the function. This is f of a, it's just a value of the function that is going to be greater than or equal than any other value of the function when x is near a. Okay, x and a are input of the function, f of a and f of x are value of the function. Okay, this is a very mathematical definition. Let's see it on the exercise. So let's identify first the local maximum of this graph. And you probably know this already. Okay, so we are going to find those high points on our graph, and since we are looking for local maximum, we are just focusing on the y values because that is the value of the function. Okay, so it is interesting because here we are going to include 3. Okay, although we know that 3 is going to be the absolute maximum value because 3 is the highest value for the function. Okay, but we are going to consider 3 also as a local maximum because if we focus only on this part here, 3 satisfies this definition where f of a, which in this case is 3, it will be greater than any other value of the function if we just surround this region here. Okay, so it's going to be 3 and 2.8. Okay, local minimum. So the definition for local minimum is going to be the same wording. The only thing that is going to be different, I'm going to just copy and paste this, and you will see what I'm going to change. We're just going to change just this sign. Okay. Okay, so we're talking about local, so it is important to understand that when we are looking for local, we need to have an open interval. We need to have a region around that point. So instead of local minimum for this graph, there is non-local minimum. Why? Because you might focus on these points here, okay? But local minimum is going to be defined. Any local extreme value is going to be defined in an open interval, not on the endpoints, okay? There is nothing surrounding this point, not on the left side. For example, here, let me focus on the point that is on the origin. This point here has a neighborhood to its right, but nothing on the left, all right? So this is not going to satisfy the definition for the local minimum in a specific region or in a neighborhood, okay? So we are not going to consider this as a local minimum. So this graph doesn't have local minimum. The absolute extreme values are easily to understand because it's just, if we are looking for the absolute maximum, if I can write absolute maximum, it's going to be from the local maximum. We can take them. Which one is the greater? Well, it's 3. Local maximum, absolute maximum of this graph is 3. Absolute minimum, on the other hand, now we can consider those endpoints, and it is 0. Okay. Okay, any question on this? So this is a good example of what I want you to do with the draft of the class. With the draft of the class, right now, because I already wrote all the test number 1 material, I'm not expecting you to write anything on the draft. Okay, so you don't need to worry right now about writing on the project. But you can modify as you will. For example, this is part of the draft of the class, and I gave you here a definition for local maximum, local minimum. In an open interval is a function value containing a region of the function domain that results to be the maximum value of function f in that region. This is just a draft, okay? And my intention with the draft is just to at least put the information that's important, but not necessarily it has the ideal wording, something that could be understandable by everyone, okay? So this is a good opportunity to go to the draft and maybe erase this and change or rephrase this definition in your own words, something that you will understand easily later in the future when you need to go back to this topic on future math classes. Okay, so that's what I want you to do with the draft at the moment. To read something, you say, well, this doesn't make sense, or this is not going to help me. Change it, edit it, modify as you will. All right. Any question? So we are going to continue with transformation. We are going to finish the 2 exercises that are on the draft of transformation. Those 3 exercises on the draft are the example of the 3 type of exercises with transformation that I want you to understand, because those 3 examples resemble what you are going to see on the test. Okay. So we are going to start with this one, and this one is interesting because the parent function of this particular exercise is not a function that we can see on the library of parent function. We cannot, in this case, it would be impossible to use the library of parent function because this function here is not part of the basic functions. This function is just made up. And more interesting is that we don't have its equation. The only thing that we have is its name, f of x, and the graph. That's all what we have. So how are we going to proceed and to understand this modification of f of x if we don't have neither the equation or it is not a basic function that we can find in the library of parent function? In that case, when that happens, what we need to do is to look at the graph and identify the key points. What is a key point? A key point is those points that basically define the shape of the graph. Let's focus just on this part here. This is like a triangle, right? Well, this left part or this left region of the graph is like a triangle. It has 3 points here that define the shape. So these points are going to be its key points, okay? Because from point, let's say point A to point B, there is a line. So that line is defined by those 2 points. So those are key points. So what we want to do is, first, let me erase this. Once we understand the shape of the graph, then let's identify those key points that make that shape, or that support that shape, or key points that are the basis for that shape. Then we get the coordinate of those points, -6, 0. So that is my first key point. -3, 3. Another one here. We have this one here. That's at the origin, 0, 0. We have one here, 1, 1. And the last one, we have 3, -2. So those are my key points. How many key points does this graph have, or this function have? 1, 2, 3, 4, 5. 5 key points that determine the shape of the graph. So the key point of f are -6, 0, -3, 3, 0, 0, 1, 1, and then 3, -2. Zooming out, and then we have the first part. Any question? Okay. Okay. Now let's go to this part that it might throw you off a little bit. So in this exercise, who is the parent function? The parent function is f of x. Okay, that is the parent function. The new function is p of x. P of x is depend or is based on f of x, because we can see here that the equation for p of x is a modification of f of x. And I know it might confuse you now because we are not working with exact numbers of variables. We are just talking in function notation. F of x is the parent function. P of x is going to be the new function that is based on f of x. So let me erase this. We need to identify those modifications on the parent function that made up p of x. I'm going to highlight those modifications. Those modifications is this negative here in front of f, this 3 in this part in front of x, and this one. Okay? So that's the first thing that you want to do. Compare the new function with its parent function and identify those differences. Those differences are the transformation that are happening here. Now, once we identify the differences, we need to describe or the effect of those transformations. And that is why you want to go to the second table on the review, where the transformation are described, where the effect of the transformation are presented in an abstract and general way in math. So you will need to read through them, and you will need to understand to know how to apply those rules or those specifications in a specific exercise like this one. Okay? When we are going to identify I'm going to erase this. When we are going to identify the transformations, we want to follow the order of operation. The order of operation says it's pendant. We start from the parenthesis, exponent, and so on. If we follow that order in this particular part, in this particular exercise, we are going to have a hint or an assistant to identify which category of transformation we are describing. That means that we are going to have a help on identify if the transformation is going to be horizontal or vertical. Remember that to know if the transformation is horizontal or vertical, we need to know, or we need to identify if that transformation is happening to the input group or to the output group. Okay? So let me put here, you can see there. Okay. So let me first write the parent function here. Anything highlighted, anything inside the argument of the function belongs to the input group. Okay? The rest, anything outside, belongs to the output group. So we go here and we are seeing three transformations, three things that are different. We are going to follow the order operation. That puts us to focus on this parenthesis. But these parentheses are the argument of, or close the argument of the function. Oh, so this is the input group. So this multiplication of 3 to x is affecting the input group. That's going to tell us, oh, that transformation, that first transformation that we are going to identify is a horizontal transformation. Why? Because it's happening on the input group. The effect is on the input group. me put this in a more natural way. Okay, so help me on this. What is the description of this transformation? So the transformation is because this 3 times x. 3, we are going multiplying in the argument of the function a factor of 3. What is the effect, or how would you describe that transformation? And what I want you to do is to go to the review no, this is the review. No, I want you to go to the draft. Okay, and when we start graphing techniques, transformations, so we have the description of the transformation, the category, and the effect on them. Okay, so what I want you to do is to identify, let me take a screenshot and let me bring it to our notebook. Okay, so this is what I want you to do during the exercise. You go to the draft, and we know that we have a 3 times x that is part of the input group. So we are going to this table here, and we need to identify that operation. We start from vertical shift. Well, here is subtracting and adding and subtracting to the output group. So this one is not the one that we are going to use to describe what's happening there. Here, horizontal shift, we are having a addition or subtraction in the input group. Again, this is not what is going to describe that transformation. Then we have stress and compression, and we have 2 types of stress and compression. We have the stress and compression vertically. That is when a factor is multiplied to the output group of the function, or we have the horizontal stress or compression. That is when a factor is in the input group. See that C here? C is occupying the space of 3 in the exercise. So this is what's happening there. Okay, we have identified that 3 is in the input group and is being multiplied to x. So then we are going, once we identify the type of transformation and its category, what is the change of the graph? So here we are going to read, we are going to stretch horizontally if C, which is the factor, is greater than 0 or less than 1. The value of C in the exercise is 3. Let me put it here. C is equal 3. So a stretch horizontally is not the description of what's happening there. Let's see the other case. Compress horizontally if C, which is the value of C in our case, is 3, is greater than 1. Oh, so this is what's happening in the transformation. Compress horizontally if C is greater than 1. So let's describe that here, because we need to describe the transformation happening. So what we are going to do, we know that it's already horizontally. So we are going to say compress horizontally. Horizontally, let me double check my spelling check. compressed horizontally, okay, by a factor, okay, and this is the exact wording that I want you to use. By a factor of what? Well, we have 3 there, but let's go back to the table again and let's see what is going to be the change on the coordinates. Multiply by 1 over c of the x coordinates. Remember that we are in the horizontal category. 1 over c is the reciprocal of c. Oh, so our value in our exercise, the value of c is 3. So we need to multiply by the reciprocal of 3. The reciprocal of 3 is going to be 1/3. So the factor that we are going to use to compress horizontally is going to be 1/3, not 3. Careful there. If we are working horizontally, that factor in front of x is what we are going to do is to use the reciprocal. Compress horizontally by a factor of 1/3. And 1/3 makes sense with compression, because when we are dividing, we are making shorter that value. Okay? Compression, dividing, or at least multiplying by a fraction, or by not by a whole number. Okay? A number that is going to be less than 1. Any questions? Okay. Let me make space aquí. I'm going to do this. I'm going to erase this. We don't need it. I'm going to move this to here. And let's focus just only now on the exercise. So we have 3 differences. We already finished with the input group. Now we go outside. Transformation number 2. That is outside the input group, so that is going to be vertical. What we have is a negative in front of f. So that is going to be our reflection. And it is vertical. So the reflection is over the y-axis or the x-axis. Make it a question. Let me know. Reflection about or over. Reflection about which axis? X-axis. Okay. Yeah. Reflection about the x-axis. Transformation number 3, sorry, is also vertical because we are working on the output group. So we have +1. So what's going to happen with our graph? What is the effect of +1 in the output group? Anyone? What's the effect of +1 in the graph? How can we describe this? And Jacqueline, I like that you use the word unit. Okay, see that when we are going to multiply, factor, when we are going to shift or add, unit. So I can simplify up by 1 unit. Okay, so those are the 3 transformations. We have described those differences on the equation. Okay, so those are the description, but the description of the transformation, but the transformation will have also an operation that we are going to apply to the coordinates. So we have, remember that we have the x coordinate and we have the y coordinates. Any transformation that is going to be horizontal is going to affect the x coordinates. What we want to do is to create an equation based on the description. Compress horizontally by a factor of 1/3. This meaning, the meaning of this transformation means that we are going to multiply all the x coordinates by 1/3. That's all that what we are going to do to modify or to change the x coordinates. When we have multiple transformations in the same category, for example, transformation number 2 and transformation number 3, so we need to be careful there because we need to construct an equation that makes sense. So we have a reflection about the x-axis. We know that that's a negative value times the output. So if we follow the order operation, multiplication goes first, goes before addition, because up by 1 unit, the operation that we are going to use is adding 1 to the output group. So we are going to start with minus y, so that is reflection about the x-axis, plus 1. And these two equations that what we are going to do, or what we are going to use to modify the key points. Let me copy and paste the key points here. So those are the key points. And now we are going to use these equations, this one for x and this one for y, to modify the x and y coordinate of the key points. Okay? Okay, so I'm gonna take a space on the right side of my notebook so we can see clearly how we change the coordinates. So the key point for P of x are going to be based on the equations for changing x and changing y. Okay, so let me use this color green, blue for x. So I know that I need to multiply all the x coordinates by 1/3. Okay, so -6 times 1/3 is going to be +2. Correct. Let me put all this here. Okay. -3 times -1/3. -3 times -1/3. What's that product? What's the value? Is 1. Thank you, Jacqueline. 0 times -1/3. 0. +1, -1/3. -0.33 or -1/3. Okay, and then +3 times -1/3 is going to be -1. Okay, let's do the same for the y coordinates. We are going to change it based on the equation that we have for the y coordinates. So what do we have here? So we have 1/3. Okay, so now -6, -0, 3, 0, 1, and -1, those are my y coordinates. So 0, we plug in 0 in this equation, and the value is going to be +1 because -0 plus 1, or negative times 0, anything times 0 is going to be 0, plus 1, the value is 1. -3 plus 1 it is -2. I'm not writing those operations here, but if you need me to write those operations here, how are we changing the values, the y values, from f of x to p of x, let me know, okay? We are using this equation here. I just talking about, we are solving the equation while we speak, okay? But if you want me to write down those steps, let me know. Okay, so 0, -0 plus 1, so that is going to give us 1. -1 times, -1 plus 1, that's going to be 0. And -2 times -1 is going to be +2 plus 1, that is going to give us 3. Any question with this? Okay, so I'm gonna copy these guys here. I'm gonna put them here. So we have the key point for p of x, and then the last thing that we want to do is to this thing. Give me a moment. Let me put this in my pocket. Okay. What we want to do is now to plot those points in the coordinate plane or the Cartesian plane. Okay. So +2 and 1, +2. Well, it's not +2. Yeah, it's +2. Yeah. Let's make sure that we have all the numbers correct before we plot those points. Okay. So +2. Okay, you seeing about right? Okay, so we have +2 and 1. We got this point. Let me see again. -1. Yeah. Okay. So let's finish this, and then we are going to check if it makes sense or not. Okay. So then we have 1, -2. That's that point. So let me put this here. Let me put this here. Then we have 0 and 1. Here is that guy. So 0 and 1. Then we have -1/3 and 0. It should be around here. So that point here is -1/3 and 0. And then we have -1 and 3. And then we connect the points. Let's see if it makes sense with the graph. So that's what we have. Let me just take a screenshot of this. And then let me take a screenshot of this as well to compare them side by side. Okay. So what we have a reflection over about the x-axis because we have a vertical reflection. So it makes sense that now these two points, right, that those two peaks now are pointing down. Okay, I feel comfortable there. That's one thing. If it seems good about good. Let's see. Maybe if we can focus on this point, well, we see that that point maybe now is not at 0, it goes to 1. So it looks like it went up 1. Okay. And then what we have, these two endpoints here. Okay, what I'm doing, this is not something that you need to do, just something that I like to do just to make sense. Well, does my transformation make sense? So I like to compare what it changed from the parent function to the new function. Okay, and that is going to help me to verify that my numbers are correct. Okay, remember, I can do math, but I want to make sense with math, and math need to make sense. Okay, if I do math and doesn't make sense, well, let's try find why it doesn't make sense, why it bothers you. Okay, your instinct always going to tell you something. Okay, what do you think? I would like to know what are your thoughts about this. Did I do it right? Did I make a mistake? Let me know. Does it make sense with you what I just presented here? This is very important. Remember, this is not just me speaking. We are going to interact with the class. Okay, so take a moment, analyze this, make sure that you are understanding everything, every step. If we are agree on what we have, then we can move on. Okay, so let's have 1 to 2 minutes to reflect upon this. Negative y plus 1. Okay. So we are focusing on this equation. This equation is the one that we are going to use to modify the y coordinates. But why? How do we know that we need to modify the y coordinate? Based on the vertical transformations. So we have two vertical transformations. One of them is our reflection. Our vertical reflection, I'm going to zoom into the table of transformation. Okay, this is the table that you have on the graph. Vertical reflection. How does it look in a graph? Oh, it's a negative in front of f. So it's a negative value that is being multiplied to the output group. Okay. That negative implies that we are going to multiply all the y coordinates by -1. That is how I get this negative here. This negative here is based on this negative here that we have identified in the new function. The description of that negative or that transformation is reflection about the x-axis. Reflection about the x-axis, and how we change the coordinates is by multiplying by 1 all the y coordinates. So this is negative y coordinate, or the negative y. That is how we got the negative y. Did I answer that part of your question? Okay. The plus one is because we have a +1 here, and that is vertical shift. We have a plus k here. we are adding something to the output group. K is positive. So raise the graph by K units, and the change on the coordinates is add K. So K in our exercise is 1. So add 1 to the Y coordinate. So Y plus 1. Okay. So we combine these two. To create the equation that we are going to use to modify the Y coordinates. Okay. Okay. So, anyone have found my mistake in this exercise? Okay, there's a mistake here. Focus on the operations. Operation that applies to the Y coordinate. Did I change something? Did I make something? What do you think? Is there something wrong with this and this? First, correct. Okay. Why did I do this? Because this is very common, and negative is just a tiny line that in the stress or on the rush of the test, a negative is always going to bother us. Okay. So I wanted to do this because I want you to always pay attention of what we are doing. See what I did? I made a mistake, and everything at the end is going to be wrong. For that tiny mistake. When I was making sense of this, what happened with these endpoints? Well, they are flipped. Why are they flipped? If there is no reflection about the y-axis, well, because I added a negative here. That negative doesn't belong there. Okay. So let's change this. Let's correct our exercise. So that negative, the only thing that the negative is going to do is that our values here are going to flip, because now we don't have a negative there. And hence, this one are going to be, this one is negative, this one is negative, this one is positive, and this one is positive. Okay, so let's go back to this and let's plot this point to have now the correct graph. Okay, I want you to be honest with me. Did you feel that I was doing something wrong and you didn't speak? Okay, that's what I want. I want you always to, if you feel something that is off, stop me and just speak about that. Let's try to find out what's happening. Okay, that's how I want to do the class. Okay, sometimes I'm going to make mistake on purpose. Sometimes I'm going to make mistake because I'm making a mistake. Okay, even though I have been teaching this class for many years, mistake will happen. Okay, so I want you always to participate in the class. If you feel something that you see something that or feel something that is off from what I'm presenting, stop me, ask the question. Don't stop. I want you to always speak up. If you feel something, speak up. I'm going to always listen to you. Okay. So let's do this again, and now let's do it correctly. And we are going to then, I'm going to leave that one here to then compare the one that is correct with the one that is incorrect. This one is incorrect. Okay, so -2, 1, -1, -2, so 0 and 1, 1/3 and 0 is around here, and then 1 and 3. We connect the points. Okay, let me put this thing here. Let's go and then compare these three. The one that is correct is on the left side. The one that is incorrect is on the right side. So this makes sense that those two peaks that were up now is pointing down because we have a reflection about the x-axis. Okay. Going up 1 unit makes sense with this one. Okay. And the last thing is these endpoints. Okay. Now these endpoints makes more sense with the one that we have on the left side, not on the right side, because on the right side it was reflected about the y-axis. Okay. Any question now with this exercise? What you have seen here, outside of the mistake was on purpose because that's a common mistake that always happens when we are working with this type of exercises. We change just one tiny negative and everything gets wrong. Okay. Oh, forget negatives. That's negative. The worst enemy in math, in a math course, is the negative because it's a tiny line, and sometimes fractions. Okay. So always pay attention to those small details. Okay, so what you have seen me here doing is all the written words I want you to present me on the assessment. Okay, if you are going to see an exercise this same type, okay, this is the written word that I need to create. Following all what I did here is what I'm going to guide you to answer the assessment correctly and get the full credit. Okay, and this class is also being recorded, so you can go back to here and review all the written work. The other type of transformation that we are going to do, exercise of transformation that we are going to do, is the following. We are given the parent function. This is the parent function. And then we have transformations, but this transformation, the only thing that we have is the discretion. So shift left 2 unit. Left, this is horizontal. That means that we are going to affect the input group. How do I go? Where is the input group here? Anything inside the absolute values. So left 2 units, go left. In horizontal transformation, it means that we are going to add 2 to the x coordinate, add 2 to the input group. So that is the first modification. We did this one. Shift up 3 units. This is vertical. So we are going to add 3 to the output, and I'm going to carry on the transformations. Okay, so we already did the first transformation. Now we are going to add the second transformation, which is adding 3 to the output group, and then reflect about the y-axis. Reflection about the y-axis. Is this vertical or horizontal? Reflection about the y-axis. Is it vertical or horizontal? The y-axis is this one here. Okay, so reflection about the y-axis is, I don't know if this makes sense what I did here, but it's a reflection about the y-axis. Is that a horizontal reflection or a vertical reflection? What do you think? You there? Okay, Jordan, you are asking me it is horizontal. Okay, careful with I didn't catch who spoke, but I think you who spoke. I think you said horizontal, and horizontal is correct. The reflection might cause you a little bit of confusion when we describe them. Reflection about the y-axis, maybe your brain think, oh, that's vertical because that is the y coordinate there. No. When we said reflection about the y-axis, it is a horizontal reflection. Okay? A negative in front of x. All right? Questions? So we got the equation of the new function, okay? And then we need to graph the new function. How are we going to graph the new function? We go to the parent functions. We know that this is the absolute value function. From the absolute value has 3 key points: -1, +1, 0, 0, and then we have 1 and +1. So the new function, I'm going to call the new function p of x, just to have consistency. P of x is going to be the absolute value of negative x plus 2 plus 3, because we go 3 units up. Okay. Okay, so we go 3 units up. So let's practice. Tell me on the chat. Take a minute or two, maybe 3 minutes. I want you to write and put on the chat the new points of p of x based on those transformations. Okay, you are going to tell me what are the new points, the coordinates. Okay, we have negative x plus 2. Okay, all that is in the input group. So remember that we are going to affect the x-axis, the x coordinates, and then we have a +3 in the output group. That is going to affect the y coordinate. Okay, so let's take a few minutes. When you have your answer, please type them on the chat. Timothy, I do not understand what you wrote there. You can just write the 3 coordinates. Okay, but I prefer just to write this way. I'm just going to write the key points. Okay, the key point of the absolute value. Okay, so this is what I want you to write. I just wrote those to Jacqueline. I'm sorry. Let me write them to all of you. So this is what I want to see from you. Just the final answer. Then we are going to discuss how we got those. The what, Timothy? Okay. But the only thing that we need for absolute values, so just 3 points, because with that we got the shape. Careful. Remember the shape of an absolute value function. Okay, I only have Timothy's answer. I'll give you 1 more minute. Before that, whenever you have doubt how to modify the coordinates, remember of the operation that we need to apply, and how we get those operations. For example, we have +3. Jacqueline, go ahead. Okay, so Jacqueline is asking about what is the effect of the negative sign. Okay, Jacqueline, me estás refiriendo al el negativo al frente de x, ¿verdad? Okay, Jacqueline is referring to the negative in front of x. So, Jacqueline, si por ejemplo cuando tú utilizas -1, pues ese negativo tiene dos negativos. Negativo el que está al frente de la x y el negativo del -1. Cuando tú multiplicas dos negativos, eso se convierte en positivo. ¿Entendiste esa parte? Perfecto. Okay, so we just discussed about what is the effect of two negatives in a row when we are multiplying. When we are multiplying two negative, for example, when we take -1 and we put it here to get the new value, we have two negatives in a row. When we multiply, that becomes a positive value. Okay. Depends. not always. Sometimes the negative is part of the equation, and we want to leave it there. We don't want to modify too much the equation. We just want to understand the equation. Okay. All right. Careful with this one. This one is interesting. Let's do the operation for the y coordinate. This is just y plus 3. So we are going to take all the y coordinates and we are going to add them by 3, right? So 1 plus 3, 4, 0 plus 3, 3, 1 plus 3, 4. We got that. Easy, right? What's gonna happen with the x coordinate? What is the operation that we are going to apply to the x coordinates? Before going to there, let's explore the effect of adding 2 in the input group. Okay, so this is the decimal graphing calculator. Okay, let me create the key points. So we can then see what is the effect of having a plus 2 in the input group and why it goes to the left when we are adding. Sometimes thing in math doesn't make sense initially, so we need to go and explore what's happening there. So I'm going to create the second equation. P of x is going to be absolute value of x plus 2, and it went to the left. We are going to get there, yeah. But I want just before negative x, let's explore plus 2. What is plus 2 doing with the x coordinates? And let me change the color of this one. So the one that is green is the one that the new function. Okay. So maybe to make things easier to read, I'm going to limit the domain of this function. So negative 1 equals x. Unfortunately, in our class, I wish I have more time so we can play with decimals. I don't want to do that on our class because then we are going to lose time. So, but usually I like to always use decimals so we can explore how we can use math to other things. Okay, I'm going sideways a little bit. This is opening a parenthesis. Let me show you just a quick example of what I do in class, or what we can do in math, in decimals. Okay, I don't know if you recognize this downtown, okay, but we can create, and this is usually what I do with math. I create animation, I create themes for video games or something like that. This is very simple. This is a little bit quirky, but this is something that we can do on decimal. Okay, so we can create different kind of animation using math, and that's what I like to present math in a way that we can use it in our future. Okay, so that is all for that part. So closing parenthesis. Let's go back to our class. All right, why are you undefined? I don't know. Okay. So this is going to be -2, and this is going to be -2. Okay, so the green graph is the one that was moved to the left by 2 units. It's the one that we add 2 to the input group, and it went to the left. Let's focus on these 2 points. This one that it is here. Can I do? Maybe. I'm going to, let me put this here, and then I'm going to take a screenshot so we can analyze this from my notebook. I think it's going to be easier. Okay. The one that in green, this one is y equals x or p of x, and let me put it here. P of x equal absolute value plus 2. The one that is in red is the parent function f of x equals absolute value of x. Let's focus on the x coordinates, and let's start with this one. Here in this one, the x value is 0. Okay, and this point was moved to the left 2 units. 2 units. And in this point, the x value is, or the x coordinate is -2. But that's interesting because we added 2 to the x in the transformation. Why are we not getting +2? Instead, we are getting -2. Well, that means that the effect on the x coordinates when we are working with shift horizontally with shift that are horizontal in the category of horizontal, the x coordinates, whenever we are adding to the input, what we are going to do is to subtract. Okay, it's going to be the opposite. So the operation that we are going to apply to the x coordinates is going to be like the opposite of what we are seeing on the equation. Oh, we are seeing a +2. So the operation that we are going to apply to the x coordinate is going to be x minus 2. Okay, and that makes sense with this 0 and this -2. The same with, well, this one, we have these two that are overlapping, so it's going to be difficult there. But if we focus on these 2 points, we can see that the effect of adding 2 to the input group means that we are going to subtract 2 to the x coordinates. Okay? So we know that the operation that we are going to do here to the x is to subtract by 2. Okay? But there's a negative in front of x. And what is then is going to be the effect of that negative? Do I put the negative here, or do I surround this by negative? What do you think? Let's go back and explore what is going to be the effect of the negative in front of x. What happened there? What happened with the negative in front of x? What happened with now with the green graph? And why is that? What just happened when we add that negative in front there? Let me put it, okay. So I'm going to put them side by side like this way. Maybe I can close this. Full screen show tabs only. Okay. So don't see that well. So the y-axis is here. Okay. Now this graph went from -2, right? It was reflected about the y-axis. The y-axis is here. Okay, so that is a reflection of the y-axis. A reflection about the y-axis. That is why now we are seeing the green graph on 2. Okay. So our question now will be, do I put just a negative in front of x, or do I need to enclose all these within parentheses? Let's explore what should happen. We have two possibilities. Okay, which one is the one that is correct? Well, let's explore that. Let's identify that with the numbers. Okay, let's try that. Okay, so if we are going to modify the x coordinates of p of x, and we are working with this first point, okay, I want to know this value. I know, well, let's work with the second value, not with the first one yet, because the one that we have on reference on the graph is the second value. Okay. In the graph what it is telling me that my x value on this point needs to be +2, not -2. Okay, that point, that x value, that x coordinate need to be x equals 2, not -2. So which of these two operations here will give me +2 here and not -2? Which one do you think is going to give me +2 and not -2? Which one? The first one, correct. Okay, because when we plug in the first one is this one. I'm gonna write it here. When we plug in x equals 0 into this equation, right? Or to modify the x value, so let me erase this. I plug in 0 into the x value. So let me just put it like this. So we have, okay, I should have started writing better. I'm sorry for that. It's not a good writing. So 0 minus 2, when we simplify this is equal to -2 times negative times -2, and that is going to be of +2. Okay, so we had doubts on which operation we need to use, but we use our graphing calculator, we use our resources, and we make sense to math. Okay, not only we need to just memorize math, we need to know how to make sense with math. We have resources, we have technology to confirm what we are doing. All right, so +2, and then the rest of the points we can get, because now we know what is the operation of the of that we are going to use to modify the x coordinates. Okay, so -1 minus 2 is -3 times 3, so +3. Then -1, this one is going to be, say one more time, -3. Okay, let's see. Okay, you plug in -1 here, so -1 minus 2. Inside the parentheses we got -3, but the negative in outside. The last one you got 3. Okay. Okay. So it will be 1 minus 2. So we have a positive and we have a negative. That is going to be a subtraction. So negative 1 and then positive 1. Okay, I think you added 1 and 2. And what you needed to do there was to subtract because the difference of signs. Does that make sense? Okay. So because in Desmos we already got that graph, we can confirm those points. So 1 and 4. So we have this 2 and 3. Wait. Oh no. I'm sorry. I think I gave you the wrong operation. I was focusing on all the stuff. Let me erase this one. Okay, so the points that I'm looking for are 2 and 0. I'm looking for 1 and 1, and I'm looking for 3 and 1. And with this exercise, we got 3 and 4, 2 and 3, and 1 and 4. Let me verify. Okay. I'm sorry. I needed to add plus 3. Plus 3. So we have, okay, I got scared for a moment there because I thought I was giving you the wrong answers, but no. So we have 2 and 3. We have 1 and 4. It is there, 1 and 4. And we have 3 and 4. Okay, I give you the correct answer. Okay, I'm sorry, I got scared a little bit there. It's just I forgot to add 3 to our graph. Okay, because I forgot to put the vertical transformation there. Okay, so this is the graph with the resulting graph after the the 3 transformation. One category is horizontal and the other category is vertical. Okay. Any question with this? Okay. Does it make sense? Did you understand why I was lost at first because I forgot to put plus 3 on the graph? Okay. No question here. Are we good here? Perfect. Okay. Okay, so this is what I want you to do with math. I want you to explore. Okay, again, you have all the technology, you have the resources, we have technology that is available for us from the internet. It is free. We can play with all this, and this is going to help you to understand math, not in a technical way. It's not, instead of critically, and that's what I want to do. All right, so we are going to go to piecewise defined function. We have 25 more minutes to do it. I believe we are going to do it because I'm going to show you the steps to graph piecewise defined function. Piecewise defined functions are not difficult. Okay, it's just at the beginning, well, you might get scared because of the notation. Okay, but if you follow this step, it's going to be very easy to draw piecewise defined functions. The first thing that you want to do with piecewise defined function is to identify that we have multiple pieces, and those pieces are based on these conditions. These conditions are partition of the domain, and the definition of those pieces are the equation that belongs to those partition of the domains. So what I do first is to write piece number 1 is the one that it is defined with all the x less than 0, all the negative value for x, and piece number 2. Okay, so we have 2 pieces. And then we are going to do 3 or 4 steps. That is going to be depending on the equation or the definition of the piece. Okay, I'm going to do 2 examples. One where we are going to do 3 steps, and the other one where we are going to do 4 steps. Okay, so we are going to start working with piece number 1. Okay, that is x plus 1 plus x if x is less than 0. Okay, and the goal is to graph this piecewise defined function. Step number 1, we are going to identify the parent function and the key points, or the number of key points that we need in order to graph that parent function. Okay, parent function. What is the parent function here? Okay, remember, parent function, we have square, cube, root, cube root, absolute value, rational. What is the name of the parent function that define 1 plus x? Fs equal x. What is the name? I'm looking for the name. What is the name of the parent function? The parent function that makes this definition, 1 plus x. What type of equation is the 1 plus x? Type of equation. The type of equation, what I'm looking for is linear. Okay. So 1 plus x is based on a linear function. The IG is a linear function, yeah. It's based on a linear function, okay? See what I did? I went to the table of parent function and identified the type of equation or function, and I know that 1 plus x is a linear function. And then how many key points do we need to draw a line? How many key points? If we are going to draw a line, how many key points or how many points do we use to draw a line? We could do 3, but let's think about the minimum amount of points that we need to draw a line. Two. It is 2. Okay. Okay. So the amount of key points that we need to draw a line are only 2. When we look at the table of parent function, how many key points? Just 2. Okay, 2 points. You said 3. Yes, we could draw a line with 3 points, but those 3 points need to be contained in the same line. If we put 3 points that are not aligned, we are going to draw a triangle. Okay, so 2 points, with 2 points, we can draw a line. 2 points, a line. We connect them with a line. Okay, so that is step number 1. Step number 2. We are going to focus on the boundaries. Boundaries of the, that's not good color. We're going to focus on the boundaries of that partition or that piece. Well, the boundaries, it says we are going to apply 1 plus x whenever the value of x is less than 0. And here what you want to do is to write the interval notation. Why we want to write the interval notation? Because that way we can identify the left and right boundaries. Left and right boundaries are going to be important. Can you tell me what will be the left boundary and the right boundary? And if we need to use square brackets or parentheses, okay, based on this, how we can translate x minus x less than 0. Okay, this is an inequality notation. What we want to do is to translate from inequality notation to interval notation. So that way we can see who is the left boundary, if we need to use a square bracket or a parenthesis, and who is the right boundary, and if we need to use a parenthesis or a square bracket. So how are we going to do this? X needs to be less than 0, x less than 0. So x doesn't have like a left boundary. When x doesn't have a left boundary, it goes to the infinite. And it goes to the negative infinite, if I can write an infinite here. All right? Negative infinite, x less than 0. And we are going to use a parenthesis because an infinite is not a number, it's just an expression. It is an expression. On the right side, we have 0. Okay? The value of x will stop at 0. It will not include 0, so we are going to use a parenthesis. So we know that the left side is an infinite, and we know that the right side is not included. Okay? The left side is an infinite, and the right side is not included. This is going to be important because now on step number 3, we are going to use this to get the key points. In step number 3, we are going to get the key points. Okay, so infinite is not a number. Okay, so we cannot use infinite to get a point for this line. So I'm going to select a different value of x that satisfies this condition. Any value that is between negative infinite and 0 is going to be a good value to use for this particular piece of the function. So because we have from negative infinite to 0, we have an infinite amount of choices, we want to use the easiest value to work with. And that value in this interval is going to be -1. So I'm going to use -1 as a point, as a value for x, to identify what will be what will be the y value of piece number 1 when x is equal to -1. So I know that the y value will be defined by the equation 1 plus x. The value of x that I'm using here, this is an evaluation. Okay, what I'm doing is an evaluation of the equation or the function to get a point, and a specific point. So when x is -1, the y value is 0. So that is going to give me a point, and that point is going to be -1, 0. -1, it is part of this interval. Okay, it is between -infinity and 0. It means that -1 is part of the domain that it is defined for 1 plus x, piece number 1. So this point here, we are going to use a solid dot when we are going to plot this point. Why? Because it's part of the graph. Okay, we are going to use a solid dot. We know that after this point, we are going to continue because it goes to the infinity, to the negative infinity. So we are going to use a point and an arrow to represent that part of the graph when we are going to plot or sketch the graph. That is going to make more sense just in a moment when I take the Cartesian plane and start working with the graph. Okay? The right side, the right boundary is 0 and it is not included. So here we are going to do something that you need to take into consideration because this is like a trick. Because 0 is not part of that domain. 0 is not part of that domain, it's just the right boundary. But we want to know where piece number 1 ends. Okay? And to know where piece number 1 ends, then we need to evaluate piece number 1 at 0. We are going to get a y value, but that is not going to be a point on the graph. That is going to be just a location. And where we are going to have just a location, not a point on the graph, what are we going to use? A solid dot, an empty dot, an arrow? Let me know which one it is. I'm going to evaluate now x, the y value of that piece, of piece number 1, when x is equal 0. So 1 plus 0 equals 1. So we have a coordinate, 0, positive 1. But this is not part of piece number 1. So how can we represent this location correctly? Empty dot. Yes, Benjamin, we're going to use an empty dot because this is just only location. Okay, with an empty dot, because what we are going to do here is just to identify only location. Okay. Do I have? Let me grab one coordinate plane. Okay. So now we are going to plot these points. Okay, we are going to plot -1, 0. So -1 is going to be here. -1, 0. I'm going to zoom in just in a moment. I just want to plot them. And then we have 0 and 1. Okay. This grid here, the unit is not defined. So you are free to define the unit as you want, as long you are consistent with the units. So for me, each line is going to represent a value of 1, but for you, it could be 2 lines is going to be a value of 1. Okay, so those are the 2 points that I'm going to use to draw this line. Okay, that is piece number 1. See that I use a solid dot here, just to location to know where it ends. I use an empty dot to know where it ends. It is just a location, not a point on the graph. I use a solid dot when x was equal 1 because that's a point on the graph. But since I know that the left boundary goes to the infinite, I use an arrow to represent continuation to the left side. Okay? Any question? All right, so I'm going to do these same steps with piece number 2. So now I'm gonna erase this. I'm gonna erase this, and I'm going to do that here, piece number 2. Okay, and we are going to stop. This is the last exercise that we are going to do because we are finishing our class. We are about 8 more minutes. We have about 8 more minutes. So on Wednesday we go quickly and we do one more exercise of this, and then we start like checking our technical, practicing our technical stuff for getting ready for the quiz. Okay. Peace. Okay, piece number 2. Step number 1. We are going to identify parent function. This is a square and the number of key points that we need. We need 3 because this is a square. Step number 2, boundaries. So we know that we have x need to be greater than or equal to 0. So if we translate this into an interval notation, it's going to be from 0 using a square bracket because we are going to include 0 to the infinite. Okay, so we have the left boundary, it is included, and we have the right boundary, which is an infinite. So right boundary is infinite. Okay, when we go to step number 3, we need points. So we are going to get points for the left and right boundary. In the right boundary, we have x equals 0. This is included. So y is equal x to the power of 2. That's just 0. So we have a point here, which is 0, 0, and this one is included. Okay, that one is included. For the right boundary, we have an infinite, so we cannot use infinite, so I'm going to use the next one that is easier to use, 1. So I got 1, y then is going to be 1, and I have the point 1, 1, and this is going to be a dot. Also, maybe I could use an arrow. Let's see. So with these 2, I have 2 points, but this parent function, the parent function here is an square. This is a square function. I need 3 points. 3 points is that how much I need. So that is where step number 4 comes to play. Oh, I don't know how you say it. But it's when we go to step number 4, because now we need an extra point. The 2 points that we got from the boundaries are not enough to sketch this piece of the function. So I'm going to use x equal 2. With x equal 2, I'm going to get y is equal 4, and that is going to be a point. So 2, 2, and I'm going to use an arrow and a solid dot. Okay, so no, I'm not going to use an arrow on 1 and 1. I'm going to use an arrow on 2 and 4. 2 and 4. Okay, because that is the rightmost point that I have for that piece. So what I'm going to do now is, first, let's move this so we can follow and track all this. So the first point is 0, 0. So that is at the origin. Should move if I can. The first point is 0, 0. The other point is 1 and 1. And the other one, so 2, 3, 4, I think it's around here, is 2 and 4. And the shape, it is a parabola. Careful, this is a parabola. You need to make the shape of a parabola. And I did an arrow. And that is how we graph a piecewise defined function. To have a better representation of that graph, let me go here. That is the graph that I just drew. And that's how we follow the steps to draw a piecewise defined function. Any question? Okay. Are you understanding everything? Are you following everything that I'm presenting here? Okay. Perfect. Let me take a screenshot of who is here and who is not. Okay. Okay, class. Is there no questions? Thank you for being here today. Remember, I'm going to be available via email. Don't worry too much about the project yet. What I want you is to get ready to now the quiz, practice, and the review and the home test. Okay. Starting from test number 2 is when you are going to start writing on the project. And what you are going to be writing is what I'm going to be presenting here. Okay. Right now I am focusing more on the exercises because you already got writing information on the draft. Okay, the draft is yours. Please read it, understand it, and if you need to do any modification, do so. Okay, that is part of the project, and that's going to be important because I want you to use that document for your next math courses. Okay, it's going to help you. Okay, so I'm gonna let you go. Thank you one more time. Have a great rest of the day. I'm doing tutoring Tuesday and Thursday. I'm going to make an announcement tomorrow to give you my tutoring shift. So in case you want to go and visit me during tutoring day, it is online. You can go and we can continue practicing if you have any question about the class. Okay. Well, thank you everyone. Again, have a great rest of the day, and let me know if you have any question via email.